Hi, I'm Dr. Paul Mason, and I'm going to speak a little bit about the definition of a planet. And we want to think about what the modern definition of the planet is, but first of all, why do we need a modern definition as opposed to the ancient definition, what we've always thought a planet is? And so we have to first think about what that is. So the ancient definition of a planet is one of the 5 objects seen moving in the sky that aren't the stars. And these are Mercury, Venus, Mars, Jupiter, and Saturn. And this depicts an occasion where 4 of those are seen in the evening sky. So actually the morning sky. And so we these planets were moved around in the sky, and they were given a lot of prestige, and even given the days of the week. We think of the sun and the moon and the 5 planets, and we are reminded of the days of the week: Sunday, Monday, Tuesday, and so on. And so those are named after the planets. What about the subsequent knowledge? The idea of a planet, what we mean by a planet, must change as our knowledge changes. So the reason why we need to have a modern definition of a planet is that our understanding of planets has changed. Copernicus's definition of a planet was simply that a planet is one of several objects that orbit the sun, and that includes the Earth. And so the objects in the sky moving among the stars didn't include the Earth. Copernicus realized that the Earth must be included, and here is his diagram with the sun in the center, and the Mercury, Venus, Earth, Mars, Jupiter, Saturn, and then a sphere of stars out far. And so since 1543, this has been our view of what the definition of what a planet is. Well, the asteroid belt began to make things change because a number of asteroids were discovered, starting with Ceres in 1801, and others, Pallas, Vesta, and Juno, and plenty of others. And so here it depicts literally thousands, and there's some that are called the Trojans and Greeks that are out in either leading or behind Jupiter in its orbit around the sun. In the inner solar system, we have all of these. So could we consider these to be planets? Well, it was deemed that all of these, Ceres was the largest, all of these were much smaller than any of the planets and known at that time. And so these were called minor planets or asteroids, and many were found in the asteroid belt. So that made it a little bit easier. We could just think of still the planets not having Ceres be a planet, or the others are of these thousands of these things being a planet. Now, the same thing in more modern times was found starting with the discovery of Pluto in 1930, and other objects began to be discovered, especially in the 1990s and then the 2000s, and now we know of many Kuiper belt objects, not this many, but we do know of many Kuiper belt objects that are in a belt-like structure like asteroids. The difference is that these are out beyond Neptune, most of them, and extend well beyond that and beyond Pluto's orbit. That Pluto is a member of that Kuiper belt, and so is Eris, the largest member to have been discovered so far. And so these added to the idea that we needed to think about what do we mean by a planet, because Pluto, having been discovered in 1930, had gone more than 50 years without having any kind of rivals in this region, but now we know there are many, and this required that we had to have a change in how we did that. So if we think about what could be done for that, and this is the actual definition adopted by the International Astronomical Union, and that a planet is a celestial body that has three properties, and it must have all three to be a planet. If it has only A and B here, it is considered a dwarf planet. So for a planet, it has to be in an orbit around the sun or another star. All right, so that means it can't be a moon. So the moon and all the moons of Jupiter, these cannot be considered planets. Not really even how big they are. It doesn't really matter. And it goes for exoplanets too. They have to be sufficiently massive, big enough in terms of their mass for its self-gravity to overcome the solid body forces and form a nearly round shape. So this means it needs to be big, and this makes these interesting because a planet has geology. It has sometimes, at least in the past, some structural processes have taken place, and whereas it's just not a rock floating out in space. And the third thing is that it's cleared the neighborhood around its orbit. And we know that the planets in the solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, all have very clear orbits. Occasionally objects will come in and collide with those, but we don't have a large belt of objects with thousands, except in the region between Mars and Jupiter. That's the asteroid belt, and in the region beyond Neptune, which is the Kuiper belt. So in those regions, we can have objects that meet A and B. So in an orbit around the sun and sufficient mass to be round, these are the dwarf planets. So A and B satisfy the requirement for being a dwarf planet. But to be a planet, to be a true planet, it has to have cleared the neighborhood around its orbit so that it doesn't have any other objects in its orbit that are of significant size. And so that is the modern definition of a planet.